Hello and konnichiwa from Mitsubishi Electric. Below contribution is prepared by application engineers, by Toshinari Hirai, located in Fukuoka, and by myself, by Eugen Stump, located in Düsseldorf. We would like to proceed with talking about motivation and hesitation of using silicon carbide power devices. In this presentation, we would like to touch such topics like price of electricity, reliability of power devices, and dedicated drivers. Please give me a couple of minutes for explanation of history of silicon carbide at Mitsubishi Electric. Please allow me to start on bottom of this slide. This history has started with small chip area with 1 × 1 square millimeter. This chip area has been gradually increased to 3 square, 5 square, and finally to 10 square millimeter. As first steps, prototypes are built in order to show and to evaluate capability and advantages of silicon carbide material. The actual utilization of silicon carbide in power devices has been performed between 2010 and 2020. In this time, first generation of silicon carbide was utilized. With increased production of silicon carbide power devices, the second generation is introduced. Today, silicon carbide chips are used in the air conditionings, in UPS, in elevators, up to medium voltage applications like propulsion and DC-DC in railway application. Let's talk firstly about motivation. One of this motivation is price of electricity. On PCM 2022, on Bodo's podium discussion, we presented already using of silicon carbide in residential application. In case such application run more as 12 hours per day, like aircon, like heat pump, the commercial break-even point of silicon carbide versus silicon would occur within 1 year of operation. Let's move to Germany. Let's take a look on German railways on Deutsche Bahn. According to newspapers, German railways needs additional 2 billion euro in order to pay electricity bill. The reason of such sudden supplementary payment could be price for industrial electricity. This price rise from 8 euro cent in 2000 up to 40 euro cent in 2022 in this year. The price for industrial electricity is similar to residential one. It is a philosophical question whether such high price will remain for long time. My intention is to show the impact of high electricity price on commercial benefit causing by using of silicon carbide power devices by higher efficiency. The effect of higher efficiency will be visible by using of mission profile of commuter train. This example or this profile is a part of discussion in shift-to-rail community in Europe. The same profile is used in Mitsubishi Electric paper dated by 2020. This paper shows energy saving by introduction of silicon carbide, 3.3 kilowatt silicon carbide devices instead of silicon power devices in same package. Package is LV100. And we assume that no further changing occurred. The energy saving is more than half considering acceleration and braking conditions only. Applying of 40 euro cent per kilowatt hour into this simulation will provide results that break-even point is possible within couple of years, not within decades. The question whether the proposed mission profile is real one, whether this mission profile is best case for using of silicon carbide technology is again philosophical or rhetorical question. My intention is to motivate you for commercial calculation by using of silicon carbide power module, and this calculation we can perform together by using of available methodology, which was explained in our paper in 2020. Visiting railway exhibition in Berlin, Innotrans, asking why silicon carbide is not used today in railway applications, in railway propulsion application, I frequently get answers that today's reliability of silicon carbide is unknown. I would like to raise this question whether reliability or unknown reliability is really reason for hesitation. With this slide, the answer is there is no reason for hesitation. There is a survey about using of silicon carbide power devices in propulsion application, in traction application. This survey presents 50 different projects, 50 different train types in operation. The earliest commissioning is done in 2016, means over 5 years in operation, over 5 years of field experience. The majority of projects use silicon carbide power devices manufactured by Mitsubishi Electric. The question for gate oxide stability is still the most frequent asked question, the most frequent concern. This issue is reported as solved by evidence many years ago. Otherwise, using of silicon carbide power devices in such conservative and safety-focused application like railway will be impossible. Furthermore, Mitsubishi Electric make additional efforts for increasing of reliability to suppress early and random failures. This is possible by strict screening process after chip production or chip manufacturing and additional screening of assembled power devices. Avoiding of bipolar current through the body diode by utilization of Schottky barrier diode helps suppressing of field failures. Improving of quality factor shall push all expected failures behind specification limits. What is the remain hesitation and how to remove it? Availability of compatible packaging will accelerate acceptance of silicon carbide power modules, will accelerate first moves in silicon carbide direction. For this purpose, silicon carbide chips are utilized in standard power modules so-called 62mm package. This package is frequently used in Asia and well accepted in railway auxiliary applications. Comparing of performance between silicon and silicon carbides shows amazing result presented on the right side of this slide. Further step to decrease hesitation is availability of dedicated drivers. His solution from company Hirai. This is Japanese company. The great feature is utilizing of RTC, real-time controller. RTC is used in order to suppress short-circuit energy and enlarge silicon carbide time for safe, slow emergency turn-off. Further possibility is to use drivers from next Japanese supplier from Tamura. The feature of Tamura's driver is relatively low stray capacitance, avoiding parasitic turn-on causing by high voltage transient, by high dV/dt. And finally, driver from power integration. Here we would like to highlight dedicated driver for 400A 1200 volt dual package with well-known feature of active clamping. Finally, let me spend additional and last minute with line-up of our power modules using today silicon carbide technology. Beginning with left side, two DPIPMs modules are indicated. Blocking voltage is 600 volt. Dedicated application is one-phase home appliances application like air conditioning. As next, high voltage power modules are represented. Blocking voltages are 1700 volt and 3.3 kilovolt. The area for industrial application is mainly occupied by power modules with blocking voltage of 1200 volt. The best seller in dual power module with current rating of 800 amp. That's all from Toshinari Hirai and myself from Eugen Stump. I hope the next wide band gap event will be organized as present event. In my humble opinion, discussions after presentations, after and during dinner are available for all of us. Thank you for your time.